Now, our success criteria is to identify the horizontal asymptotes and evaluate the limits of rational functions at infinity through real-life examples, and also to determine the size of the pupil with an infinite amount of light by evaluating the limits of rational function graphically and numerically. What are limits at infinity? So this is the symbol which is written in the form of 8, but horizontally it is the symbol which is which is used to describe the behavior of the limits. Now, limit infinity means the symbol infinity, actually it is a very large number, or minus infinity could be a very small numbers. Now, if the x is decreasing, okay, so we can write it as x approaches to negative infinity, and if x is increasing, then we can say that x is positive infinity. Now, this is decreasing without the point, and plus infinity means increasing without bound. Now, if the y value is negative infinity, it means the y value is increasing without bound, or y value is, if it is equals to positive infinity, it means the y values are increasing without bound. What are horizontal asymptotes? Whenever we explain the behavior of any function when x is either increasing without bound or x is decreasing without bound, when we show these things analytically by means of an equation, then it means algebraically it indicates the horizontal asymptote, and they are said to be limits at infinity. So if I am writing limit x approaches to positive or negative infinity and it is equals to some number, or limit x approaches to negative infinity of a function equals to some number, it means they are used to express the horizontal asymptote, and the equation is said to be limits at infinity. Now remember that the vertical asymptotes, if we will have the vertical asymptotes, so in order to express the vertical asymptotes, it means limit is approaching to certain number from the left and from the right side, and the y value is equals to either positive infinity or negative infinity. So that means if here the y values is plus or minus infinity, means that we are finding the vertical asymptotes, and this means infinite limits. Now we already know there are two kinds of limits. One is infinite limit that shows the vertical asymptote, and limits at infinity that shows the horizontal asymptote. Now here, let's write the equation and try to find out how can we write the equation and how can we determine the horizontal asymptote analytically. So in order to express the limits at infinity, we one time write limit x approaches to negative infinity, and one time we write limit x approaches to positive infinity. Now on this side the x is negative x, which means it is negative infinity. Now hide all the side and only look at the left side and tell me, when x is going to the negative infinity, what is happening to the graph? The graph is getting here on this side horizontals, right? Trying to make a horizontal line. So read the y value. So the y value at this side is negative 1. Now, when x is approaching to the positive infinity, what is happening? What is happening here? Look at this one. Right here, when it is approaching to the positive infinity, the y value is here, for example, 2. So this is how we express our limits. Now look at this graph and write. If limit x is approaching to negative infinity, what is happening? Negative infinity is here, right? So here, what is the y value? Look at the y value. It is equals to 1. Now, what if limit of this function when it is approaching to the positive infinity? It means over here positive infinity. What is happening? Graph is over here. So what is the y value? Read it. It is also equals to 1. In this graph, when limit is x is approaching to the negative infinity, means here, what is the y value? Y is going here, right? So read it. What is the y value? It is equals to 2. And when limit x is approaching to the positive infinity, what is happening here? Positive infinity. So this is the graph. So what is the y value? The y value is negative 1. Okay, so here is a graph from your textbook. Now let's see when limit x is approaching to negative infinity. Negative infinity is here. Now you don't need to read the graph over here. No, you will read the graph when it is approaching to negative infinity. So here, what is the y value here? Read it. Go ahead. What is it? Approximately 2. So when x is approaching to positive infinity, what is the y value? Look here. Read it. What is the y value here? It is 0. Here in this graph, when limit is approaching to the negative infinity, read what is it equals to? It is equals to 0. Now, when it is approaching to the positive infinity, here is it, okay? Positive infinity, read the y value. Here it is negative 1. So look at this one. How can we evaluate the limits when x is approaching to the infinity? Remember, infinity means that we need the very big number. Infinity means after the 0, we have to make the numbers, we have to write the numbers which are increasing. So I would suggest always write x and y start from let's suppose 10 to the power of 0. Always start from 10 to the power 0. Then write here 10 to the power of 1. Then write 10 to the power of 2. Then write 10 to the power of 3. Then write 10 to the power of 4 and so on. And find out the values. So write in the calculator only this side, and if you have a graphic calculator, you write the equation, go to the menu, then go to the table, and you will see the table like this, right? In the table, write the y value only this side. You can't write the limit in the graph. X square minus 1 divided by x square plus 1. When you will write 10 to the power 0, your answer will be 0. 10 to the power 1, you will see that your answer will be 0.980. At least write the 3 digits after the decimal. When the power is 10 to the power of 2, you will get 0.9998. When it will be 10 to the power of 3, you will get 0.999. On 10 to the power of 4, it will be 9999. Okay, so what have you seen? So since you want to find out from the positive infinity, so you will see approximate this one, right? Approximate this one. Approximate. It is 0.98. 0.98 means 1, right? 0.998, it is also 1. 0.999, it's also 1. 0.99999, it's also 1. So almost all the numbers are coming to the 1. So it is answer from the left side will be 1. Now, what if the numbers are very different? For example, 1 is 0, 1 is 10, 1 is 100, 1 is 500, and so on. So, what is happening when you are going towards the positive infinity? Okay, when you are increasing, here also the numbers are very much increasing. So, in that case, the answer will be positive infinity. Now what happened when, how you will make the table when x is approaching to negative infinity? Look at the number line, right? On the number line, this is 0. Negative infinity is this side, right? So how can you write? Here you can write 10 to the power of 0, 10 to the power of 1 with the negative sign, 10 to the power of 2 with the negative sign, 10 to the power of 3 with the negative sign. 5 are enough. Even 0 is not required. But if you are writing 0, it's fine. So we will write x and y, right? X and y. So better always make 5 columns. In the fifth, 1, 2, 3, 4, 5, fifth column from the left hand side, right? When you want to find out from the left hand side, you write the 0 in the last column, then minus 10 to the power of 0, then negative 10 to the power of 1, negative 10 to the power of 2, negative 10 to the power of 3. This shows that you are going like this. Okay, so when you will write, you will get negative 5, you will get negative 32.778, you will get negative 303, you will get negative negative 32.78 here. One second please. So here on the 0 you will get negative 5, on this one you will get the error, that is undefined. On negative 10 to the power of 1, you will get negative 32.778. Here negative 10 to the power of 2, you will get negative 303, and here you will get 3003. Now look at this. As you are moving to the left side, what is happening? The numbers are jumping, very much jumping, but with the negative side, right? So they are increasing or they are decreasing? They are decreasing. So it will be negative infinity. Now here you have to create a graph or sketch a graph showing the following condition. Now whenever you have the means, this comes in my mind, but you can write anything. Look at this. Here it is positive infinity for the y. Here it is negative infinity for the y. Here you will have positive infinity for x, and here you will have negative infinity for the x value, right? So here x, here y, and here positive y. Okay, so when x is approaching to negative infinity, the y value is 3. So it means on my y value there is a horizontal asymptote when it is approaching to the negative infinity. Now when x is approaching to 5, it means on my x axis the value is 5. Then there is a positive infinity y value, which means that it is showing a vertical asymptote on 5. Now when x is approaching to positive infinity, the graph is again going down. So how can we graph it? Let's see here. First of all, they are saying that when x is approaching to negative infinity, y value is 3. So I can go like that a little bit. When x is approaching to 5, y value is positive infinity. So make a curve from here. Let's make a 5 over here. You can make anything. Then on positive infinity, the value is negative infinity. It means when x is approaching to positive infinity, yani when it is going here, okay, so the value is negative infinity. So let's suppose if on the 5 it is like that, but on the positive infinity you have to show the negative infinity like this. So you can make anything, but showing the following conditions. Okay, one thing I have seen over here, they are saying that x is approaching to 5. They are not indicating that 5 from the left side or 5 from the right side. If they are not indicating, it means I have to make 5 from the both side positive infinity, right? So it means that from the right side also it will be positive infinity. Then it will going to the positive infinity, yani x is approaching, x is increasing. So at that part when the x is increasing, the y value is negative infinity. So now it is correct. So this could be a condition, because the third condition is a bit difficult, that when it is approaching to positive infinity, it has to be down. So this is the way, because it doesn't represent an actual equations graph, so you can create it with your own mind.